Welcome everyone to OTF Connects SketchUp 3D Modeling for Real World Math Part 2 with our presenter Colin Pattison. And as some of you may remember, Colin joins us from the Chatham area and he's a teacher of grade 7 and 8. If you were here for Part 1, you'll know that this is some pretty neat stuff that you're going to hear about tonight. I'm excited to hear about Part 2. I've had a peek at a few of the things that you'll be doing. It looks pretty amazing. It's a great way to finish off your school year. So let's get ourselves started tonight. I'm going to hand it over to Colin.
Okay. Hi, everyone. How's it going? I'm Colin Pattison, and like Trish just mentioned in that wonderful introduction, I just recently did a workshop, Part 1, on using Minecraft in the classroom. And to be honest, when it comes to 3D modeling and working specifically with math in 3D, my first sort of love was SketchUp. So I think you're going to find tonight I work pretty quickly in this program, and I've been using it for a long time. I've seen the value that it has to offer for my students in terms of engagement and understanding. And I'm hoping I can transfer that through mitosis or meiosis to you today. Hopefully you can take a little bit of that home as well. So I'll be walking you through some of the tools that are in this program. Right off of the bat, the new one, which is SketchUp for Schools, that's the tool that we will be working with tonight, was pushed out maybe about 1.5 years ago, and it does unfortunately work only on a Chromebook or on a laptop or a desktop computer. So if you're working on an iPad, you're kind of out of luck. You technically are able to open the Workspace page, but it doesn't function terribly well on a tablet. So we're going to be working with laptops, Chromebooks, and desktop computers in mind tonight. If you're working with an iOS device, we'll have some suggestions for similar programs that you can access on those devices as well. So we're going to move right along here, and I gave this introduction in the last workshop. I'm a grade 7-8 teacher. I'm a father to a 2-year-old. I am now a father to a 2-month-old as well, so I'm kind of burning the candle at both ends as of late, but they're fantastic, wonderful kids. I have a lovely wife named Jen, who is also a teacher in LKDSB as well. I do dabble a lot with 3D printers and 3D modeling in the classroom, and I've made some friends in that department as well, and we'll talk about them a little bit tonight too. I'm also a huge lover of language. So I'm a language arts teacher. I teach currently right now mathematics for grade 8. I teach my language arts curriculum, I teach health, and I'm a science teacher too. So if you haven't yet pasted your Twitter handle in the chat section of the window, if you can put that in right now, some of the best connections I've got right now in terms of teachers that I connect with actually came from Twitter, and in a lot of cases it came from a random message, a spur-of-the-moment thing, either somebody who direct messaged me on Twitter or responded to something that I posted in the past, and it's made for maybe some of the more engaging projects that I use with my students. So it's a really great way to connect, and if you haven't already done this, make sure that you're following the OTF social media handles as well. So we've had some people already kind of commenting on the window. I know I've got up on the slide right now. If you haven't pasted this in just yet, make sure that you, at some point, type a message in here. Why is it that you want to work in 3D? Why do you want to come to a workshop on SketchUp? What is it that you want to do with your students? We are a small but mighty group today, so I'm hoping that that actually yields some really great benefits because it's going to give us a little bit more time to dig into the program itself, hopefully give you a little bit of time to work on some personal projects, and it'll give you the chance to ask me some questions as well. Because SketchUp is a super powerful program, but it does have some ornery points to it. So if we can give you a chance to actually work in the software tonight, then hopefully we can get some of those kinks worked out, and when you go back to your classroom, it's going to be a little bit quicker and more efficient to get those projects together. So I'll kind of start with a quote from one of my absolute favorite people in the entire world, which is Stuart McLean. "We may not be big, but we are small." And I think that that's a good way to look at the group tonight. We're a small but powerful group. So a couple of quick housekeeping questions. We'll try and get through these quickly so that we can get onto the software, we're going to use the clip art button for this one as well. Are you currently teaching math? And I am, so I'm going to drop a check mark on the check mark on the screen. Okay, awesome. I love the addition of the text box on here. So currently teaching math, but on leave at the moment. That's okay. Sometimes when you're on leave or away from the classroom, that's the perfect opportunity to look at awesome projects that you can bring back once you're live in the classroom again. Also gives you a little bit of a chance to kind of get your feet wet with the program, because I don't know, students sometimes are like sharks and they smell blood in the water, and maybe if you're a little bit nervous with using the software yourself, they get a little bit kind of apprehensive about using software too. And what I've kind of found with my own students in the class is when I feel like something is a piece of cake or a walk in the park, that usually goes on to my students as well. So most people are teaching math at the moment. We have one person not teaching math, or maybe that's the comment that's posted up on the screen too. We'll move on to the next question here. So what grade do you teach? This is going to be an important one as well. I'm a grade 7-8 teacher, so a lot of my stuff is going to be kind of dictated toward that area. I wholeheartedly believe that SketchUp's a really easy platform to learn. So even if you're teaching in the junior grades as well, I think that there's a lot of depth that you can work with here. But there's also some alternatives that we can talk about, some more simple pieces of software that you can use with your students as well. And we've got a French immersion teacher here too. That's awesome. So I will be telling you about one of the reasons why I am super excited tonight, because I just noticed that SketchUp pushed out a change that should have come a really long time ago, and I don't know why it took them so long to bring this out. But literally live in the panel tonight when I was pulling some stuff together, I noticed that they added the text tool. And I know it seems as though that should have already been there, and it kind of was, but for a really long time the only thing that was in the actual SketchUp workspace was a 3D text tool, which looks super awesome, and it's great for 3D printing things if that's your bag. But when it comes to me using it as a tool in the math classroom, a lot of the time I want my kids to do the visual part, and I want them to be able to build the models, but I need them to explain too. And that means I need to make use of paragraph text. And it's kind of something that we talked about in the part 1 of this workshop, in the Minecraft one. For a long time, the only way to add text to a Minecraft workspace was to drop signs on. The text was super limited. And Minecraft Education Edition, they added the ability to add something called chalkboards. And with a chalkboard, you can write paragraph text. That's basically what SketchUp has dropped in this new update, is the ability for you to tag sections of your design with paragraph text. And to me, that's going to be a massive game changer, not only in my own classroom, but for your classrooms as well. So when it comes to looking at French immersion integration, that text tool is going to be huge, because as long as you access your international keyboard at the tabs on the bottom of your laptop or your Chromebook or desktop computer, then that means when you're creating models in SketchUp, you can have all of your students describing those things in French as well. So that kind of app smashing feature is going to be super powerful. So hopefully we can explore that tonight too. Okay, so next one, again, kind of an important question to look at. What kinds of technology do you have access to? We're going to stick with the clip art button. Do you have iPads, laptops, Chromebooks, BYOD, some weird mix of everything that's on the screen here? I know for a long time my classroom was a garbage bag full of everything, including old laptops of my own that I would bring in to increase the number of devices in my class. And if you've never looked at doing that before, bringing in things that look like outdated technology to a lot of people, an old laptop can function really, really well when you open up a Chrome browser and something like SketchUp that doesn't take a lot of processing speed on your computer to be able to run. Again, we've got somebody with one-to-one iPads here, so I will try and make sure that we talk about some of those iPad-friendly tools today. I'll give you a heads up right now. One of the best ones that you can access if you're looking for design work is a program called Onshape. And Onshape is technically professional grade CAD software, but they have a lot of tutorials out there that make it really easy for students to understand how they can use it and how they can create models. And again, the fact that it's fully available on all mobile devices, including actually phones, makes it a really useful tool. All right, next question. Have you ever used a 3D printer before? So I'm curious about the answers on this one, because when it comes to working with models in SketchUp, I always think in centimeters and millimeters, because if I design my projects that way, then it means if I ever want to use a 3D printer, if I want to print that model, I've already designed it inherently so that it's able to come out on a print bed, and it's a really powerful piece of engagement to be able to show a kid that they designed something in a piece of software, they sent it to a printer, and now it popped up and they're able to actually hold it in their hand. So we've got a couple of people saying, yes, I have done it. A couple of people saying no. Somebody saying, no, I've never done it before, but I do want to. So I'm just going to kind of pause on this screen for a second, because I'll touch on this later on in the presentation as well, but I want to make sure that I don't miss this point. If you've never used a 3D printer before, there is a very, 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 very good chance that your local public library already has 3D printers. They probably have technicians who are assigned to those 3D printers to be able to handle files from people in the community who have library cards and want to print their own things. Your 3D prints are either going to be free or extremely cheap. In Chatham-Kent here, the way it's basically set up is they have an intro to 3D printing program that you have to sign up for prior to using the 3D printers. But it's less of a workshop and more of a check and balance to make sure that you don't send them files that are incorrectly designed, so that they have to fix a bunch of stuff. So once you take that workshop, it's about a 2-hour-long workshop. They give you authorization to use their 3D printers, and when I go to design a file in SketchUp, all I have to do is open up my email, upload the file to a web form at the public library. The technician gets that file. They handle all of the printing for me. They print it in-house, and then I get an email saying that my print is ready, and I pick it up the same way as I would request a book from a different public library. I just pick it up like a hold at the front counter. And again, there is a cost associated to it, but it's very minimal. It's based on the grams of filament that are used. So as long as you're designing small objects that might sit on a desktop, they're super cheap. And again, coming back full circle, that's why I always try and kind of think in centimeters and millimeters when I'm working on projects in the class. Because if I want to print those things off, or even have my students go and print their own stuff outside of the classroom, it's really, really engaging. All right, so where are you at with technology? Are you super confident with technology? Do you feel like you're pretty comfortable? Are you kind of dipping your feet in the water, or do you absolutely hate this? I doubt we're going to have anybody in this bottom right-hand corner section. I don't think you'd be here tonight if you hate technology, but I mean, you're open to put a check mark or a happy face wherever you want, or maybe an angry, sad devil face if you really hate technology. I guess you can throw that in the corner in the bottom. Okay, so somebody super confident, fair amount, kind of in the middle, a little bit. Again, the great thing about SketchUp, this is one of the programs that made me kind of fall in love with math as a subject in school. So I'm hoping that I can kind of bring this to your level today to make you feel really confident in using it. And again, I think that's going to kind of translate to your students. All right. So I'm going to give you this one, and then I'm going to try and run through the next couple of slides, and then I want to get into the software so that I can show you a couple of starter projects that we can work with, and then I'll give you some time that you can actually work in SketchUp in kind of a sandbox mode. And then I'll be here kind of as a, I don't know, maybe as a office hours professor, so I can answer some of your questions and hopefully help you to troubleshoot some things on the fly here. So in a quick sentence, what is it that you want out of tonight? When we're talking 3D printers, do you want to learn how you can make something in SketchUp and send it to a 3D printer so that your students can do that? Is there a particular strand or piece of subject matter that you want to use it with? Did you hear me talk about the text tool and go, wow, that's going to be awesome for my French immersion classroom? I'm going to move to a blank slide. If you can use the text tool and type a response up here, and just following Trisha's instruction, if you hit that little triangle in the corner of the text tool, change your text to something that's a little bit larger. We've got a small group tonight, so there should be lots of space on the page to be able to type. And if you have to, if your page text isn't working, you can obviously jump into the chat window. So maybe if we can, I don't think we need a timer for this, but maybe we'll just take a couple of minutes to write some of these on the screen. So just while people are kind of finishing up the sentence that they're working on there, I'm just going to share a couple of things. Again, I wrote this one on the screen. I have been waiting for this stupid text tool for so long you have no idea, and it has driven me crazy as to why they haven't included it until now. So hopefully we can maybe brainstorm some ways that we can make use of that text tool tonight. There's a lot of people writing up things about wanting to get some project ideas tonight. So I'll tell you right off of the bat, the best thing that SketchUp is used for is angular architectural models. And maybe architectural makes it sound a little bit more intimidating than it actually is. But what I mean by that is if the things that you're looking at working with have straight lines and angles and in some cases arcs and some simple circles and cylinders, it's very, very good at producing those kinds of things very quickly. So there are some projects that it doesn't lend itself terribly well to, and it's something I talked about in the first Minecraft workshop, which is it's not great at designing organic kind of modifications. So if you picture, I love the idea of 3D printing. I would like to make a custom grip for my badminton racket. It's not going to handle that very well. It's possible to make something like that in SketchUp, but you're probably not going to want to tackle it. There are some other tools that make that kind of job a little bit easier. One of the ones that we'll talk about later on is called Vectory, which is a mesh modeling program. Vectory does a really good job of making kind of modifications to a simple shape. But if you're talking simple lines and arcs and things like that, SketchUp's amazing. So I see a post up here in the chat window saying, I use Tinkercad. Is SketchUp similar? To be honest, I would say to a certain degree, SketchUp is easier to work with. And the reason I say that is that Tinkercad is a program that uses something called primitives. So typically when you're designing a 3D model in Tinkercad, what you're actually doing is going to a little tool set on the side window and you're grabbing a 3D shape that's already been constructed and you're dropping it onto the screen. And then you get a little scale bar that allows you to change the width of that shape, the depth of the shape, the height of the shape. So an easy example to kind of split the difference for you is if I wanted to create a house in Tinkercad, my easiest way to do that is to grab either a cube or a rectangular prism and drop it onto my workspace, stretch it to the side that I want, the size that I want, and then grab a triangular prism and stack that on top and stretch it to the size that I want. Where SketchUp has kind of an easier learning curve is you can actually draw with straight lines. So instead of having to grab that primitive and then stretch it into position, I can just sketch a bunch of lines on the screen, and then I use something called a push-pull button in order to turn that thing into a 3D shape. So it means that the types of shapes that you can create are a lot more complex, and it means that when you're making changes to those shapes, you can do things like slicing off pieces of them. And I'll be showing you that in a couple of slides as well, because a really awesome project to try with your students is kicking it super old school and creating a 3D printed tech deck skate park. So if you remember these little plastic skateboards that you would use with your fingertips on your desktop to not pay attention in class, yeah, you'd create a skate park for that. And it's really easy to do because ultimately you're going to drop some cubes and stuff like that onto the screen, and then you're going to draw either arcs or lines on top of them, and then you'll use this push-pull tool to slice them up into pieces. And again, that'll make a little bit more sense once we get into the workspace. So we'll move along here. Here's a couple of quick tips and tricks. The first one is with any of these programs, whether it's Minecraft or it's SketchUp or it's Onshape or it's AutoCAD or Tinkercad or whatever program you're looking at, once you learn to visualize 3D in one of those programs, it typically transfers to all of them. So almost every one of these programs is going to have three things, either a red or a green or a blue line, and that's to help you indicate what your X, your Y, and your Z axis are. So when we take X, Y, and Z, what we end up getting together with that is 3D space that we can work with. In Minecraft, it's the same thing as taking your character's perspective and having them look around the screen. So if we can learn to visualize in 3D, it's really easy to take a look around the room that you're in and see some of the objects that you might be able to reproduce in a program like this. Second one, I said this right from the get-go. For me, whenever I'm doing a project with my students, I treat it from the standpoint of if I'm designing in 3D, then theoretically I should be able to use a 3D printer to make this thing as well. So when I'm working with larger models, typically I have my students kind of scale them down so that they fit, you know, a centimeter or a millimeter workspace, because it's really cool to be able to print your own stuff. And that gives you a lot of power when you start looking at your environment and figuring out how you can use math to make real things. The next one that's up here, and I'm just going to kind of underline this. Underlining in black is maybe not the greatest idea in the world, but and I just changed nothing on the screen. So let's see if we can, there we go. Okay, so we're going to underline this next one because it's another thing that if you start with this trick right from the beginning, then you're not going to make this mistake later on, which is to start with a template. When you're working in edu.sketchup.com/app or the alternative, which is app.sketchup.com, in the top left-hand corner, you're going to see a button that allows you to start from a template. I always start in millimeters because as soon as you start drawing shapes on the screen, it's going to automatically default to whatever system of measurement you're working in. So you can work in feet and inches, you can work in millimeters, you can work in meters. For me, I always start with millimeters, and that helps me kind of set my orientation, and it means that I'm going to be able to work with those things on a 3D printer too. And the last one that's here is to always check your geometry. And again, this is another sort of 3D printer specific tip, but I always kind of pass this one along because 3D printing is super cool. And if you can do it, you should. So it's to check your geometry. And what that means is you're always looking to close off your shapes. And when you use a program like SketchUp, it's easy to look like you have connected two lines, but actually maybe be off by a millimeter or so. So when you're making your designs in here, typically you want to make sure that you're snapping onto the corners and closing off all of your faces and your sides. And once you do that, ultimately, when you make a 3D model, you're going to do something called grouping, and once you've grouped those shapes together, then you're able to export a file called an STL file, which allows you to send it to a 3D printer. And another update for edu.sketchup.com is now they've made that option available so that you can download it straight from the program as well. Okay, so everything around you is made up of some basic shapes and numbers. I have a water bottle sitting in front of me. It's a 500 milliliter water bottle. It's basically a cylinder with a bit of a cone on the top that has another cylinder stacked on top of it. And I never really paid attention to water bottles before until I started working with 3D models, and now I see these numbers pretty naturally when I look at stuff around me. Generally, these are some of the basic shapes that we're going to work with, which is we've got our rectangular shapes, our circles, or we've got ovals in some cases, or our triangles, and obviously their sort of primitive 3D shapes become prisms and cylinders. So the difference between surface area and volume, I always find is explained really nicely using a 3D printer time lapse. So I'm going to have Trish throw this link in the chat window to the left-hand side here. It's a really short one. It's only about 1.5 minutes long. But if you can click this link, if you've never seen a 3D printer work before, this is a really good one. So maybe you can click that link, and maybe we'll set a timer for 3 minutes, let's say, and that should give people lots of time to go and watch the video and then come back to the Blackboard window. All right, so just to follow up here, if you can use your check mark button on the left-hand side just to indicate that you're back here, but that was plenty of time, so we should have everybody back in the window now. I really love that video, and I use it all the time with my students because it gives you a really clear idea of what happens when you're taking something that started in 2 dimensions and you turn it into something that's 3-dimensional. It illustrates an example that I use with my students all the time, which is a really basic surface area problem. You know, we're dealing with a rectangle that is 5 centimeters by 10 centimeters. So we learn really quickly that your formula for area is length times width. And by that we get 5 centimeters times 10 centimeters, and our answer becomes 50 centimeters squared. Now, that unit dimension becomes really important, squaring that number. But where it becomes really interesting is when we add some volume or a 3D dimension to that example. And the easiest way to do that is to make a volume problem that looks like this. 5 centimeters times 10 centimeters times 1 centimeter. So now we have a height of 1. Well, the issue is those students are going to get the same answer. And they're all going to go, wait, you can't do that because that means you still have 50 centimeters. But what we've done is we've changed that unit dimension. So to me, it's akin to taking a bunch of algebra tiles and stacking them on top of each other to make a cylinder. That's kind of the easiest way that I explain area to volume for my students, and ultimately how a 3D printer kind of functions and works. So I'm going to skip past this because I really want to get into the workspace, especially since we're small and mighty today. So I'm going to kind of cut this story short. We know that a 1.5 years ago, the world went absolutely crazy over these ridiculous fidget spinners. The first time I remember a student having one here at school, he bought it on Amazon for something like 10 bucks. He was selling it to other kids in the hallway for 30 bucks, and he was making a profit of 20 bucks in the process. And within the course of like 2 weeks, everybody had this wave of every kid that you have ever seen had 7, 8, 9, 10, 20 of these things in their backpack somewhere. So we started talking, very quickly in our math classroom about how this is a perfect example of something that fits a 3D printer because it's a really small object. I love the light up ones. I'm glad that you like those. I absolutely hated them because my kids would have them in class all the time. It's a great object because for me as a grade 8 math teacher, it's dealing with cylinders. That's the bearings that we're going to use in here. It's a reusable material that's really easy to find. We had kids, prying them out of their skateboards or out of their rollerblades, their old bearings that came from those. We had some people that got them from VCRs. And then we've got some gentle arcs that we can work with to produce these shapes. So this is an image of a 3D printed one. It's just a couple of stacked cylinders, and obviously we've got the bearing inset in the middle. So there's some pretty easy dimensions that you're going to be working with here, and I'm going to give you kind of a quick workflow on how you can do this kind of project in your class using SketchUp. So, technology gods, we are going to attempt a demo using the application sharing tool. So I'm going to switch over to the SketchUp workspace. Hopefully you've got this window in a separate tab as well. Again, the links for those are either edu.sketchup.com/app to get into the education version. And if you're having trouble with that, you can go to app.sketchup.com, which is the generic one that uses a Google domain. So I'm going to switch now to my web tour. I'm going to make sure I'm on Fidget Spinner, which I am now. And I'm going to switch, application sharing, share, and you should now see in my screen a fidget spinner in the middle of a coordinate plane. So if you could you give me a check mark if you see that, I guess? I'm looking at my participant window here just to make sure that everyone can see it. Perfect, I got one, I got two, it looks like we're live, awesome. Okay, so I'm going to tell you a couple of things about how I got this shape here in the first place. So we talked about tips and tricks. The first one is you want to make sure that you're working off of the template. When you're in SketchUp, the way that you do that is you're going to hit this triple line button in the top left-hand corner, and you'll open that up, and you're automatically going to want to go into this tab that says New Model. And you're going to see that this is where you have your templates. So the first one that's at the top is feet and inches, the second one is meters, and the third template that you'll look at is millimeters. So I always opt for millimeters because when I'm working in millimeters, it means I can work with it as a 3D printer file. So I'm working in a millimeters template right now, and this is where we're going to move to some of the hotkeys. You're going to see me sort of rotating my screen here like this. There we go. So we're on a bit of a delay. I'm watching on my participant window here, but it's not too bad at the moment. You should see the perspective kind of changing. And the way that I'm doing that is I'm using a mouse at the moment, so I'm currently using the scroll wheel in the middle, and I'm actually clicking that in order to change my perspective. If you're doing this on a keyboard, what you're going to do instead is you'll be hitting the O key on your keyboard for orbit, or you'll be looking at the tool set on the left-hand side, and at the bottom you'll see a little double arrow button here that says orbit. That's the button that you'll use to change the perspective or the angle that you're looking at. Okay, so I'm going to show you something on the right-hand side of the toolbar, a couple of things actually. First one that we'll look at is this little instructor's cap. If you're learning to use the program, you're going to want to make sure that you click that instructor's cap. Okay? The instructor's cap is going to make it so that whenever you click on a new tool, you're going to get a little dialog box in the top that's going to explain what that tool is and how it's used. So you'll see in my screen right now, it says that the orbit tool allows me to rotate my camera about the model, and then it explains some basics on the tool. I'm going to switch my hotkey here. So I'm going to hit the L button on my keyboard. That's going to change my tool set to the line tool. And you're going to see that that window changes live too. And now it gives me a description on how I can use the line tool. If I switch it to R, it's going to tell me about the rectangle tool. And if I switch it to E, it's going to give me some instructions on the eraser tool. So it sort of floats live on the right-hand side of your screen. It takes up a little bit of real estate on your workspace, but it's really worth it, especially when you're learning to use the tool set, to have that just open to give you a little bit of instruction along the way. The next thing that I'm going to show you is specific to SketchUp for Schools. And if we click this triple line button, you'll see in the bottom left-hand corner, you have a thing that says Curriculum. And if you click on that, you'll see that the first box gives you an instruction on how to use SketchUp for Schools. The second one gives you a project for students in grades K to 5. It's a turtle sandbox. The next one that's up here is the Pirate Ship Playhouse, which is for grades 6 to 8. And the next one is Mike's Malt Shop, which is for grades 9 to 12. And the great thing about these tutorials is they're completely interactive. They have a little video that floats in the top right-hand corner of the screen, and it walks your students through how to use the tool set. So this is a huge tip, and it's one that I sort of have to remind myself of sometimes. It's really easy to go in and try and teach this from a projector or a smartboard, but you need to take those tutorials when they're there. If they've designed those materials, give the devices to your kids, load the tutorial, let them work through it themselves. It's going to mean that you're freed up to kind of troubleshoot problems a little bit more, and the projects are going to come together a little bit more naturally. The next one that I'm going to show you that, to be honest, I don't use as much as I should is the Views button. It's the little snapping box for films, I guess. And when we click the Views button, you'll see that you have a couple of different perspectives that you can work with. The biggest one that I'm going to be using this for here is the top view button, and I'll show you why in a second. So I'm going to snap it right now, actually. There we go. So what this has done is made sure that the fidget spinner model that I'm looking at is oriented right at the center of my X, my Y, and my Z. And it's going to mean that I can't accidentally draw lines in 3D space. And you're going to know exactly what I mean the first time you do that, because a line is going to appear out of nowhere and you're going to think it's flat, and then when you change your perspective you're going to notice that it's kind of floating in the air. So maybe I'll see if I can do one of those right now. I try not to do them, so this is actually breaking a habit of mine. So let's see, do that, and just get a couple of things. I'm actually pretty well flat there. Okay, there we go. That's what I was looking for. So I did not want to do this, and in this case I kind of did it intentionally, but you'll see that I have this weird wireframe just kind of floating in midair. When I'm designing things, typically I want to make sure that they're attached to a plane, and when I do it, that means I'm usually trying to get things lined up on my green and red lines or my X and Y, because that means everything's flat, and then I can use that blue line to orient them in 3D. So now I'm going to go back to the Views button. I'm going to make sure that I'm on top view, which is going to center those things again. And now I'm going to take these shapes off, and I'm going to show you how I built this. So I'm up here at the Select tool, just like many other programs. You're going to use that to draw boxes around the shapes that you want to highlight, and then we can delete them. So I'm going to take that right off. And I'm going to start with the Circle tool. And another good tip and trick here is you want to get used to this tool set that's on the left-hand side. But another thing that you should really get used to is SketchUp is super intuitive. So if you think that a keyboard button is associated to a tool, it probably is. So when I go to draw a circle, I'm just going to hit C on my keyboard, and it's going to switch me to the Circle tool. Okay. The next thing that I'm going to try and show you here is whenever you're drawing shapes, in a lot of other types of software, you click your mouse button down and then you hold it and you drag something into position. But when you're working in SketchUp, you actually want to click once to start drawing a shape, and then you're going to have the option to be able to type in some dimensions. So if you start doing that right from the get-go, you can get some really precise things. So what I've done is I've oriented myself so I'm right in the center of the origin, and I've clicked once to start drawing I didn't click once. Now I've clicked once to start drawing. You can see that my circle is getting bigger and smaller. I'm just going to watch in my position window and try and make sure that you can see that. And you'll see that the blue circle is getting bigger, but the other thing that's changing is you have a measurement that's in the bottom right-hand corner of your screen. It's telling you that your radius is getting bigger and smaller as well. So if we want to design a fidget spinner, what we're working with is a bearing that has an outer dimension of about 22 millimeters. So what I need to kind of consider here is I'm going to be designing the holes for that bearing to pop into. And so that means when I go to make my circle, it can't be 22 millimeters, otherwise my bearing wouldn't fit in, so I've got to make it a little bit bigger. And the second thing that I have to remember here, and I apologize for teachers in the junior classes, I have to be aware of some terms here when it has to do with circles. So the one that I'm actually drawing in is the radius. Okay, and that's my line that goes from the center point of the circle to somewhere on the outside. So that means if I need a circle that is 22 millimeters across, then my radius has to be 11 millimeters. In this case, I want it to be a little bit bigger, so I'm going to make it 11.1. So when I'm dragging the circle, at any point, I can type some numbers in and hit enter. So even with it this big, I'll let it buffer on your screen, you should see 62.60 in the bottom right-hand corner. I'm actually just going to bypass that, and I'm going to type 11.1. If you really want to be in a good habit, you can type mm for millimeters. And then I'm going to hit enter. That's going to give me a circle that is 11.1 millimeters for a radius, or 22.2 millimeters in diameter. Let's check out this little text tool for a second, guys. So what it did here is on my tool set, I have a button, I don't know, 3/4 of the way down. And when I open that drop down, I see a couple of things. The dimension button here is this thing that looks kind of like a little cross street. And then right below, I have this new one that just got added called text. And we're always going to tag those to shapes. So I'm going to click the dimensions tool here. And I'm going to click on my circle. And you'll see that it gives me a little tag on the outside that says that my circle is 22 millimeters in diameter. Okay, so I'm going to take that off because we don't really need it, but there. Okay, next thing that I'm going to do here is, having done this with my students, I have learned this the hard way. What I need here is a bit of a guideline to show me how long the fidget spinner is going to be, because I want it to be able to spin between my index finger and my thumb. So the way that I'm going to do that is I'm just going to kind of eyeball, again, using some numbers here, and I'm just going to use kind of a basic one. So let's go 35. No, let's go bigger than that. Let's go 45 millimeters. There we go. And I'm not on my line. I've got to switch my view here. I'm going to go back to top down just for a second to top view. Now when I draw that line, I actually want to draw right on this green line. So that's going to help me to make sure that I'm centered. So now I'm going to go 45 millimeters. There we go. Okay. We don't really have this option in SketchUp, but what I'm doing here is drawing something called a construction line. It's a line that I'm not actually going to use for anything. It's just helping me to figure out where the other shape's going to go. And that's going to be the point that I'm going to put my other circle. So I'm going to click. And now when I go to draw this circle, I'm going to use that same trick. I clicked once to start drawing. I'm going to click my keyboard, and I'm actually going to type in those numbers. So now I have another circle that is 11.1 millimeters. I'm going to go to a new tool here. And what I'm going to do is go to the spot where dimensions are. So again, about 3/4 of the way down the tool set. And I'm going to see that I have an option for a protractor. And the protractor is kind of a funny one, because what you have to do is align the protractor the same way as you would lining it up with something on a piece of paper. So I'm actually going to click the center, the origin here, and then I'm going to slide my mouse up that line, and you can see that the protractor is now turned sideways. I'm going to click again, and what that's done is oriented it and given it kind of a starting point to reference. So now when I move my cursor, you're going to see that I get a dotted line appearing, and I'm trying to go real slow to watch my participant screen to see what you're seeing. And what you're going to see changing here is in the bottom right-hand corner, we have a value going up that says angle. And what I want to set this to is 120 degrees. The reason I'm setting it to 120 is I know that I'm going to want 3 of these circles, and I want to make sure that these are the same distance away from the center that the other one is at the top. So I'm going to do the same trick for the other side. I'm going to put my protractor in the center. I'm going to click once to start. I'm going to go directly up this line. I'm going to click again, and then I'm going to take that dotted line and I'm going to swing it out to 120. Okay. So now I have these 2 kind of guidelines to work with to create my angles. I'm going to go back to my line tool, and I'm going to do the same thing that I did on the top, I'm going to draw two other lines that come directly out of the center here, and they're also going to be 45 millimeters long. Another sort of pro operator trick here, SketchUp really likes to continue using the same tool, so you can see even though I've stopped drawing, it still has the line live. The way to make that tool go away so that you can move it to a new location is to just hit escape. Okay. So now I'm going to click on the center. I'm going to go back on my other guideline. I'm drawing right down that line. I'm going to make that 45 millimeters, and I'm going to hit escape, get rid of my tool. And now, pretty simple process. I'm going to create my circles on the outside. Again, those are going to be 11.1 millimeters, the same as the first one. You can see on this last one, I actually didn't type that number in. It's actually referencing the fact that we have some other circles that size here. Okay, I'm going to do this last piece pretty quickly because I want to get you into the software so that you can make some stuff too. But I'm going to go to my line tool, and I'm going to use a little hack that I use all the time in SketchUp. I'm going to chop this circle at the top up, and the way I'm going to do that is to just draw a line across the middle. And I'm going to do that for my circles at the bottom here too. Go right, that one's actually at an angle. Using my scroll wheel to zoom in here. There we go. I want to make sure that I'm right in the center. Now I'm just zooming out. I'm going to switch to another hotkey here for a second. It's another tool that you're going to have to use all the time. It's the pan tool, and the way that you get to that on your keyboard is with H. Okay, and that allows me to slide my screen across, my camera horizontally. And now I'm going to go to the line tool, and I'm going to do the same thing here. There are some faster ways that I can create this, but for the purposes of the tutorial, this is going to be the easiest one. And the last one that I'm going to do here is something called an offset, and what that means is I'm going to reference another shape somewhere on the screen, and then I'm going to make something that's either bigger or smaller. So I'm going to click on this arc at the top, and I'm just going to make a shape that's on the outside a little bit bigger, and you'll see that value is changing in the bottom right-hand corner, so I'm going to make this 3 millimeters, offset by 3. You can do that same thing for these guys on the bottom, 3 millimeters. Do this circle too, 3 millimeters. There we go. And you should see that this fidget spinner is starting to take shape. The last thing that I need to do here is I'm going to use a 2-point arc. And what that means is I'm going to grab my starting point, my ending point, and then I'm going to sort of bend that line into place. So it's the second arc tool here. I'm going to click my first point. I'm going to click my second point, and we're going to go to tangent at vertex. Again, if those aren't terms that you see as familiar, look for tangent at vertex, and then I'm going to kind of color code these other ones the same way. So I see that one going pink too, means I'm in the right spot. And I'm going to do my last one. Make sure that that connects to pink. There we go. Okay, and now you see that my shape has gone kind of this light blue color. And that means that you now have a closed surface that you can now manipulate and turn into a 3D shape. So I'm going to switch to another familiar tool that you're going to use all the time. It's the eraser. You can either click it on the left-hand tool set, or you can just hit the E button for eraser. And I'm just going to go in and I'm going to erase these guidelines. I'm going to erase these split lines that I used to chop up those circles, my little construction lines that I was working with. I'm just clicking on those to get rid of them. There we go. And now I have a shape that looks pretty familiar, just like a fidget spinner. I'm going to go to my select tool, the pointer. I'm going to click the first circle. You're going to see it goes dotted like that, and that dotted texture means that I can now work with that 2D shape and do something with it in 3D. So I'm going to delete that circle. I'm going to go to the center one, delete that. I'm going to delete the two outer ones. And now you're going to see the magic of SketchUp in action. I'm going to do that thing called orbit, which can either be accessed by the bottom of the tool set on the left, so this little double arrow thing, or if you're using a mouse, you can click your scroll wheel and drag it into position. That's going to change my view. Or I can hit O on my keyboard for orbit. All three of those things are going to get you to that tool. I'm going to rotate that into place. So you now should see this shape almost as if you're looking at it from maybe a 20-degree angle. And then I'm going to use the most powerful tool in SketchUp, which is something called push-pull. So I can either go to my screen on the left-hand side, and it's accessed about halfway down that tool set. It's this little rectangular prism with an arrow coming out of it, or on your keyboard, it's going to be P for push-pull. And you're going to see that when I hover over top of this shape, it gets this dotted texture to it. And that dotted texture means I can now use push-pull to manipulate this thing. So I'm going to click once to start manipulating, and you're going to see that I'm dragging my 3D shape into position, and I'm going to set this to 7 millimeters. That's a pretty decent shape for working with bearings and things like that. And you now have a 3D printable fidget spinner. It is not the most amazing fidget spinner in the world, but it is a fidget spinner that is basically dimensionally accurate. I'm able to export this file so that it can be printed on a 3D printer. It's super, super cheap, and it's really awesome for kids to realize that they can design this thing in a program and then actually pick it up off of a printer. So it's a good time to kind of mention another working piece here, which is when you go into the SketchUp workspace, you always want to make sure that you're saving your files. So you'll see that mine in the top says Fidget Spinner OTF. If I click on that, I can change my file name. And once I have saved my file, I have the option to do a couple of things with it. So if I click this drop down, I can save it as a SketchUp file, or I can export it as an STL. So if you want to be able to 3D print your own designs, the one that you're going to be wanting to work with is called an STL file. And the last thing that you would want to do before kind of sending that off to a 3D printer is you would use your select tool. We would draw a box around the whole shape. You would right-click it, and then you would click on Make Group. And that means I'm now done with this 3D shape. Everything's together the way that I want it to be. Then we would go to that drop-down button. We would click Export and STL. And honestly, for the purposes of printing somewhere like the Chatham-Kent Public Library, all I have to do is go to their web form, upload that STL file. It goes directly to their library text. They'll open it up in their software, and if there's a problem with it, they're either going to fix it or they're going to email me and let me know, and they're also going to tell me how much it's going to cost to print it. So super easy to do. So I'm now going to export or exit the web tour. So I'm going to hit the stop button, and I'm going to switch back to the whiteboard. And can you just give me a check mark in there if the majority of that workshop in SketchUp, or at least that active view there, was working for you? I know that there was probably a lag time there, but if you could see the majority of things on the screen, if you can just give me a check mark button. Perfect. Okay. I apologize for the fact that it's choppy, but again, you'll be able to come back to this webinar after the fact, and you'll be able to walk through some of those steps. And I have to say, it was one of the better ones that I've done, because sometimes in the middle of it, I make a mistake in my workflow too. Okay, so we are at 8:35, and I really want you to have the chance to work in SketchUp a little bit and use me as a resource, because we have this small and mighty group. I know that not everybody's going to be comfortable using the talk button, but I'm super fast on a keyboard, so if you're better to use that chat window to send me a couple of messages, and I can hopefully help you to work with a model. I think what we're going to do is we are going to skip to time to practice, and what I'd like you to try is making a super basic house. You want to make this as easy as possible for yourself. Then what you're going to do is work with rectangular prisms. The other thing that you might want to look at doing, and maybe I'll just switch to application sharing for 1 second here. So I'll switch my window in the back, and I'll show you what I mean on my view. I'm going to go to application sharing, share, and that was pretty fast. Okay, so you should see a basic model of the house here in the screen. The funny thing about SketchUp is you can make some manipulations really, really quickly here. So if I hit R for the rectangle tool, and I just grab a line on the side and I draw myself a rectangle, I can now use my push-pull tool, P. Ooh, I didn't do that accurately enough. Sorry there, guys. Do that one more time. I'll do it with lines this time. Okay. There we go. So I just drew kind of a basic cutout shape here. Now I'm going to hit P for push-pull. And I don't know why this is not wanting to create for me. Okay, I'm going to make myself a new prism. Push-pull. Okay. And now I'm going to create a line somewhere on this shape. I'm going to hit P for push-pull. And you'll see that the side of this shape goes textured. So now when I click and I slide my cursor, it chops off the side of that shape. So very quickly you can start creating pretty complex 3D models. The other one that I'm just going to show you briefly here too, if I hit the line tool, I'm going to find the midpoint of this top plane. I'm going to draw a line right down the center. If I want to make the peak of a house, and I know that you might want to try that, the way that you do that in SketchUp is kind of weird. You're going to hit M for move, or you're going to go to this little crosshair tool on the left-hand side, and I'm actually going to move this line. I'm going to move it up. So I'm going to want that line to go blue. I'm going to click it with my mouse, and I'm actually going to hold up on my keyboard. And what that does is it tells SketchUp, I don't want to move this left or right, and I don't want to move it on an angle. I literally want to go up and down. And you're going to see that that's how I'm able to kind of create that peaked shape. Okay, so there we go. Now I have a peak for the house. So we're going to give you, I guess, maybe about 10 minutes to kind of work on some things in the SketchUp workspace. We'll set a timer for this one. I'm going to be live in this window. I'm going to shut my talk button off, but I'll be live in the window. So if you have some questions for me and you want to work with the tool set, jump into the chat window, ask me there, and I will give you some answers and try and get you on the right track. Okay, so we'll start that timer now. All right, everyone. So I'm hoping that by having that ding sound go off, you're actually a little bit frustrated that you have to come back, because if you're frustrated right now, it means that this tool is working and you're getting why it can be engaging for kids. So if you can just give me a check mark in the chat stream once you're back here on the screen, you'll notice while you were away I was tossing some ideas onto a blank slide here for you, just as some easy projects that have kind of a low ceiling, easy entry point for your students to get into. I know a lot of people were talking about projects in the class. Notice most of the ones that are on here, I'm dealing with kind of small objects that can be produced on a 3D printer, and most of these ones are actually using small amounts of filament. So I know that we're at 8:49, and Trish would be telling me that I've got to watch my time now, but I'm going to squeeze every second out of this because I want to show you a couple more things. So I'm going to switch to application sharing for a second, and I'm on the right window. So I'm going to go to application sharing, SketchUp for Schools. You should see my screen live here. I'd like you all to enjoy my lovely French that I've typed on the screen specifically for you. I actually faked all of this and I was using Google Translate, but I wanted to play with this text tool to show you how powerful this really can be. And you know, I love the fact that we have a couple of French immersion people here on the chat, because I'd love to see what you do with these projects, and if you find some ways that you can incorporate SketchUp, that's going to be really awesome. I'm just going to show you what I was doing here, because I was trying to line these up so that they were all easy to see and easy to organize. I was just clicking on the text tool, and you have to attach your text to something. It can be anything that's on the screen, but I usually kind of tag it to a point. So I'm grabbing there, and then I'm kind of trying to spread them out so that they're all in the right position. So I want to make sure that when these are sort of floating in the air that I'm going to be able to see them. So I'm dragging it off to the side here, and then I'm typing in the box. One thing that you may have encountered if you were playing around with this tool, you're welcome. You're welcome for typing it, Rich. While you're playing around with this tool, if I type a longer sentence in here, so something like, my name is Colin, and right now I am typing on the screen. Oh, that was bad grammar. But that's a really long sentence. You're going to see this really annoying thing happen where the text is going to be a long string of sentence, which is not going to be what you want. You probably want a nice, well-organized little paragraph. So when you're working with longer explanation strings, just kind of cue yourself to hit the enter button after every couple of words. So when I type this out, I might do it like this. My name is Colin, enter, and I am typing on, enter, the screen. Now you enter and see it better. And now I'm going to click off to finish it. And you're going to see that it's organized a little bit more cleanly. So if you can kind of preach that to your students as well, it's going to save you some headaches because you're not going to have to move around the screen so much to see what they're writing about. I'm going to stop application sharing for a second, but I'm going to make you go crazy in a minute when I switch back to it. So a couple of ideas that were on here, you know, a pencil or writing utensil holder. This can be, pencil or writing utensil holder. This is a really great one because you can actually put stuff in it. Again, it takes up small amounts of filament, so it's pretty awesome. If you've ever come across conductive styli before, it's actually pretty easy to make your own version of a stylus using something like copper wire or bare conductive paint. If you have your students design their own styli and they paint the end of it with conductive paint and they use a couple of other hacks that you can find on the internet, then they can actually make their own styli that they can use on their own devices. iPhone cases, huge one. These dimensions are all available online. An iPhone case takes up a really small amount of filament. It fits the size of a print bed, really easy to print off. You know, growing patterns are a great one. We'll talk about mousetrap car parts. As a science teacher, I do this project every year. If you're working with a basic mousetrap, like a Victor one that you can find at the dollar store, those are really easy dimensions to design around. So doing the design work like the body of the car or the chassis, the axles or the tubes that you're going to attach the wheels to, the wheels themselves, it's a really cool project to kind of bring those dimensions to life. iPad stand is a really easy one. Custom name tags, kind of a cool hack for that is to make these sort of graffiti style. So I'm going to switch back to application sharing to show you what that can look like. Oops. Switch my window here first. Oh, there we go, on the right one, SketchUp for Schools. So you can actually see two things live on my screen here. The first is a couple of the shapes that I just kind of hacked apart to show you how easily you can build things like ramps or quarter pipes or half pipes in SketchUp. And again, you can print those on a 3D printer, and then if you have kids that actually have a real tech deck, they can produce their own little skate park using those dimensions. For me as a grade 7-8 teacher, it's a really awesome way to kind of work together all of those volume expectations, but give them a real world task that they can see the connection to the math from. But the other one that you'll see here, I didn't make a new window for it because I just wanted to get through it as quickly as possible. is kind of a flip on the name tag thing. So what I was doing here is designing sort of graffiti style letters, and I was doing that by just using some polylines. So to do it, I was going into my Views tab and making sure that I was on top down, because when I make these lines, I don't want to unintentionally draw in 3D like I showed you at the start of this workshop. So I'm going to go to top view. Sometimes you have to orbit and then hit top view and it'll snap into a position. So I've done the C and the O for my name. I'm just going to show you how quickly you can do something like an L. So I'm just going to draw one line like that. I'm going to kind of angle this up a little bit. I love graffiti, so this kind of comes naturally to me. I have some friends that were really into graffiti when I was at university. All super legal, I can tell you. There's a big sort of misshapen L. And then you'll see I'm just using the orbit tool or the scroll button on my mouse to change my orientation. And I usually do that whenever I'm going to take a 2D object and I'm going to turn it into 3D so I can see what's happening when I use push-pull. So I'm going to hit P for push-pull. And now when I drag that thing into position, I get a really cool blocky looking L. And then if I want to make sure that that's nice and close to the other ones, I'm just going to draw a box around it using the select tool. You'll see that the whole thing is now highlighted. And then I'm going to hit M for move, or I'm going to hit the crosshair on the left-hand side. I'm going to click on the corner. And this is a good kind of point to stop on for a second too. When you're moving objects on the screen in SketchUp, you're always going to want to make sure that you're moving from a particular point, because the way that you snap things into position are going to be related to that point. So now that I have this whole object selected, you'll see when I move it around the screen, it's actually snapping into position based on that corner point. So I want it to be kind of positioned somewhere around here. Maybe I want these sort of floating together a little bit. And again, if I actually wanted to 3D print this, what I would do is highlight all of these in a group. That little ramp at the bottom is kind of in the way for me, but I'd highlight all of those in a group. I'd right click, I'd go make group, and then at the top I'd go export an STL file. So you see that come out, and then I could send that over to the library for printing. I want to quickly show you these shapes here, and again, I know I'm probably ignoring Trisha's instructions here because I'm not really watching the time. I am watching it, but I'm going to squeeze all of this in. So I'm going to highlight these, and I'm going to show you how quickly you can do kind of a ramp. So selected rectangle, I'm going to draw on a flat plane. I use that orbit tool to rotate that into position. I'm going to hit P for push-pull. I give myself a cube, and now all I need to do to create that shape is I'm going to go to two-point arc, and I'm going to start at the bottom here because I want the ramp to not have a gap to it. And I'm going to click a spot on this top line. So I don't want to go all the way to the edge because on a real ramp you'd have a bit of a platform on the top. Click there, and then you can see I can bend this line. And I know, again, you're probably on a little bit of a lag, but you can see I'm bending this line into place. And ultimately I'm just drawing on the side, and then I'm going to cut this shape apart. So I'm just going to take my push-pull tool. I'm going to make sure that I have that little triangular section highlighted, and when I slide my mouse back, it's going to cut that right out. When I click again, it's going to disappear, and now I have a ramp. So it's really easy to do those types of shapes in here. You can use that same logic to create a half pipe. I'm going to do one more quick for you, and then I think I'm probably going to get cut off. So I'm going to do a rectangle on the screen, P for push-pull. I would usually use a tape measure to give myself a couple of guidelines here, but in this case I'm just going to draw some lines on. So I'm going to put an angled line there, and I'm going to put an angled line roughly in the same place. I'm kind of eyeballing. I hit my push-pull tool, and I get kind of a little kicker box that you might find at the X Games. So at this point I'm going to stop my application sharing. I'm going to go back to my presentation, and I'm going to very quickly blast through these last slides, and then I'm going to throw my hands up and say I'm done. So make sure that you're using millimeters. Turn on the application cap or the academic cap. That's the instructor. It's going to give you some live feedback while you're working. We're not going to talk about obstacles. Use local SketchUp installs. You can use old school and new school. Small group strategies, great way to kind of troubleshoot if you have less devices in your class. Make sure you're using the curriculum tutorials. That's super important. It saves time for you, makes it easier for kids to use. Here's some other pieces of tools that you can check out. Floor Planner is great for doing 2D organization of rooms. Vectory, if you haven't come across it yet, is an amazing tool. It also links to your Google account. It also has a tutorials button in the top right-hand corner that will instruct kids live in real time so that you don't have to do it. Onshape is super powerful CAD software that you can use on mobile devices, and obviously Tinkercad, which a lot of you have used. Here's some samples of some cool projects that my kids have done. This was a toy truck model that one of my kids did in class. This was a really awesome project. This was the conductive styli project. So I had groups of kids actually design the stylus itself, and then they designed a housing to go with it that would hold those models as well. This bottom model on the next slide is actually my former school, Tecumseh Public School. It actually was the first thing I ever 3D printed. It's in my hand right now on my desk. And the kid that designed this model grabbed the blueprints off of the wall in the school and designed the whole thing in SketchUp, and then we 3D printed it. The one above is a colleague of mine and her actual retirement home that she's going to be moving into. She's designed it all to spec, and she updates this model all the time. 3D print at the public library, that's what they're there for. SketchUp is awesome. It's super easy to onboard. It has Google Apps for integration, Google Apps for Education integration. You can make real stuff, and when you can do that, your kids understand why math is important. If you've got questions, we don't have enough time to ask them right now, other than maybe the 10 minutes at the end of this presentation. But if you do have some lagging questions after that, feel free to reach out to me on Twitter at Colin J. Pattison, or you can email my LKDSB account, which is colin.pattison@lkdsb.com. Thank you for participating. I'm now about to throw my hands up and say I'm officially done. Trish, you can cut me off now.
Oh, that was terrific. Thank you. And it looks like lots of people stuck around for every second they could get. I'm just going to throw into the chat a couple of things that were mentioned, just so that it's there for the recording as well, too. Some of these were suggested as options that were mentioned by other participants. So, yes, here we are. Thank you very much, Colin. I'm going to quick stop the recording.